Hello and welcome. In this lecture, we're going to be editing these things, which are haptic feedback curves. Very interesting indeed. And what are they going to be doing? Well, when we go ahead and hit play, then when we put our controller into a climbing handhold, it is going to vibrate. You can't tell it's vibrating because that's happening in my hand, but every time I put my controller in here, the correct one is vibrating. If I picked up the other controller and put it in, then that one is going to vibrate instead. So that's fantastic, and that's what we're going to be achieving in this lecture. Let's dive in and see how to use haptic feedback effects. So in the last lecture, we managed to get a log message printing out when we can climb. Now, obviously, that's no use to the player when they're actually exploring the environment and trying to climb. So what we actually want to do is provide some sort of haptic feedback via the hand controllers. So let me just show you how you can do this in Unreal. You do it via an asset called a haptic feedback effect curve. Now, if we go to our content browser, go to Add New, and down to the miscellaneous section, in here you'll see a whole host of assets to do with haptic feedback and force feedback. Now, haptic feedback and force feedback are very, very similar, basically do the same things, but will work differently on different devices. Some will require force feedback, some haptic feedback. I think that for both Oculus and the HTC Vive, we want to go down the haptic route, and there's a few different types of asset here that we can use. For example, you could do haptic feedback based on a sound wave, so you could bring in an MP3 and it could do haptic feedback based on that sound wave. It can do it based on a curve, and it can do it based on a buffer of values, so you can say, basically, I want it to be 1, then 2, and then 3, and then 1 again, and go through that buffer at a certain rate. Let me show you better with the curve. I think the curve is the easiest asset to work with. I'm going to prefix this with HFE for haptic feedback effect _, and then we'll call this the handhold rumble. And we can go ahead and open the asset and see what it looks like. If we expand out the haptic details, you can see that there is a frequency and an amplitude curve. And you can edit this like you can edit many of the curves in Unreal. You can go and add in keys in a couple of places. I'm going to add one at the 0.5 mark and at the 0 mark. And then I'm going to add one in the middle as well. And I'm going to crank up the value. Let's see, this is frequency, so it's times per second. So what's a sensible frequency? Probably something along the lines of 50 hertz would do the trick, and then we can rescale to see it. Now, as it happens, I don't believe the Vive has any frequency, doesn't really respond to frequency. It really only responds to amplitude, which is how strong that signal actually is. But you can go ahead and set it up anyway because it will work on whatever type of controller you're using. So it could be the Oculus, and I think the Oculus does support frequency. So I'm going to go ahead and increase the amplitude at the 0.25 mark, set the value. In this case, amplitude varies between 1 and 0, so 0 being off, 1 being full strength rumble. So I'm going to get it to go all the way up to 1 and then back to 0 in 0.5 of a second. So that allows us to dictate how the rumble is going to feel. Obviously, you could do a little rumble, 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 or you could just have what I'm doing. You can choose how you want that rumble to work. In fact, get a little bit creative with this curve for yourself. It's a mini challenge. Pause the video and have a go if you want to create this curve in a slightly different way. Okay, welcome back. So we're going to leave that curve where it is for now. And we're going to have a little look at what you can actually do with this curve. If we take a look at the documentation for the A player controller and search in here for haptic, you can see that in here we've got a play haptic feedback effect function, and that takes this U haptic feedback effect base, which is actually that asset curve is one of those, and then it takes the E controller hand, a scale, and a loop. And I believe scale and loop have got default values, so we don't have to worry about that. So basically, you need to get hold of your player controller and then feed it the haptic effect curve and the hand. Couldn't be simpler, right? So it's going to be your challenge for this lecture to play the effect on the hand controllers to make the controllers rumble. So find the correct player controller. I don't mind how you do that. Think creatively and try and find a player controller. Any way that you can get hold of it is okay. Reference the curve asset, so you know how to reference assets by now in Blueprint and get them in C++, and then play the haptic effect. So pause the video and have a go at this challenge. Okay, welcome back. Hopefully you had a go and it was fairly easy. So first of all, we're going to get hold of the player controller over in the C++. So where do we want to do the rumbling? Well, we want to do it where we're currently doing this UE log. So I'm going to take out the UE log, and instead we're going to try and get hold of our player controller. So I think the easiest way to do this is this actor is currently attached to another actor. So if you looked through the documentation, I had linked to this, which is the aActor get attached parent function. And if we use this, I can get hold of the aActor that is our parent, which is, as we know, a VR character. But I'm going to get hold of it as just a generic actor, because then this means that the hand controller doesn't rely on the fact that it's a VR character. So I get hold of the attached parent, and what I do want to do is try and cast it to a pawn, because I want it to be a pawn so that I can get hold of the controller that is controlling it, because a pawn has something that controls it. An actor doesn't necessarily. So we'll have an A pawn, and we'll call this, rather than actor, we'll call it a pawn, and we'll make sure we use the cast that checks whether it is of the right type. So we're going to cast it to a pawn, and then we'll need to do a null check after this, which I can do. So if pawn not equal to null pointer, if I can type correctly, then what do we want to do next? We want to get hold of the controller, so pawn arrow, and then it's going to be get, oh, it looks like we don't have the header for pawn, so let's get the header. Here's the documentation for a pawn. Let's go down, and we are going to look at, it's going to be gameplay framework, or game framework pawn.h. Go to the top of the header file, and we can go ahead and do an include. Okie doke, and then we're going to go down, and we should now be able to do a get controller. Now notice that this isn't necessarily a player controller. It's just a generic controller because this pawn could be controlled by AI. So we do want to do another cast here that casts it to a player controller. And again, will be null if it cannot do that kind of cast. And so we can store the a player controller. I'm just going to store it as controller here. And then we do another if statement. It's going to be if controller not equal to null pointer. Then we're getting there because now we have got hold of a controller. We can do a controller arrow. And again, we need to include the right thing. So what's the header file for a player controller? Again, game framework player controller. Very, very similar to the pawn. It's all part of that game framework. So we're going to do hash include the player controller.h, go back on down, and then we're going to do our play haptic effect. And this is where we need to get hold of our haptic effect. So we're going to go over to the header file now, and in where we have our, well, we don't actually have parameters yet, so let's make sure we've got some parameters. We've got default subject, sub-object. Underneath those, we're going to put some parameters, and it's going to be a U property that is edit defaults only, because I only want to set up this parameter in the defaults. And then what's the class going to be? Well, if we go over to the docs, we can see that it is class U haptic feedback effect base pointer. Then we can just call this the haptic effect. So I'm just going to copy that whole line and put it here under my parameters section. And go ahead and build. Make sure I have a semicolon on there, or it definitely won't build. And we can feed the haptic effect into our play haptic effect. and we can give it a hand as well. What is the hand? Well, it's going to be whatever the motion controller's hand is. Remember, we set that in our, where was it? Somewhere here we've got a function. Oh, it's in the header file, that's right, where we have set hand, and we're setting the motion controller hand. So if we get the motion controller arrow hand variable, that gives us which hand we are currently on, which controller are we controlling. So we can go ahead and build that. It shouldn't complain now. And indeed it doesn't. So let's go over to the blueprint, open up the BP hand controller, where we should now be able to see that the hand controller details pane has this haptic effect, which we are going to go ahead and select our curve for. We can compile it, go ahead and play, and excellent. So I already felt that there was a rumble there. I'll bring it out, bring it back in, and there's a rumble. As I go in, it rumbles. As I come out, it doesn't. In, it rumbles. Out, it doesn't. In, it rumbles. And as long as I'm inside either one of these two, it's not rumbling, but as soon as I come out and back in again, it will rumble again. So we've got ourselves some haptic feedback that will work on both controllers. You should go ahead and try that out for yourself. I just tried it on one controller. But pats on the back, and in the next lecture we'll actually look at trying to get the climbing mechanism working with the input from these controllers. See you there.